All right, everybody, Professor Cooper here. We're going to talk briefly about geom segments as one of a number of different geoms that deals with things like uncertainty or ranges over the values of either a variable or a time point. Geom segments can be used for lots of different things, but in this particular case, we are talking about a measure of dispersion, a measure of spread. It is not unlike using standard deviations or standard errors, which are used for representing sample dispersion or for the amount of confidence you have that your sample represents, let's say, a true population mean or something like that, in which case you're talking about standard errors. So geom segments are useful for this. They have a start point and an end point, and they are linear, right? And today we're going to use the World Income Inequality Database as the example data set. So I have run a glimpse just so we can remind ourselves what all is in the data set. A bunch of economic indicators, countries, and a bunch of year. These are time series, and they're often multiple observations, multiple estimates of things like income inequality, the Gini index, for example, within a given year for a given country, because there are multiple sources that are making these estimates, which we can see in the variable source, and then more details about the source. Okay, so in this case, we are just going to capture the median Gini index for a given year for the entire continent of Europe, but then we're also going to capture what you would normally see in, for example, a box plot, which is the interquartile range, which would be the box itself, where the lower end and the upper end of the box, the extremes of the box, represent the 25th and 75th percentiles, or the quantile at 0.25 of the data and the quantile 0.75 of the data, ordered. That's where we're going to go with this, and then we're going to use those values and we're going to create some segments. So the data work up front, I actually don't pipe right into ggplot this time, so I'm going to save it as an object. This is sort of an arbitrary choice. I didn't do it for any particular reason. We have the WID data set, and then I filter for Europe, but I'm also going to filter for a year after 1950 because a lot of the countries don't have a lot of observations before 1950, so what's the point? If you're in the class, then you know, and you've worked with these data a fair amount now, you know that the observations really start to pick up around 1950 and moving forward. Then I'm going to use a grouping. I'm going to do a group by year. So because I'm only grouping by year, this means that I should, whatever comes next, whether it's a mutate or a summarize, is going to be for the entire continent for that year. It's not going to be by country. It's not going to be by sub-region. It's going to be by the entire sample. And in this case, that sample is Europe because I filtered for it. So the grouping by year means we're going to get the median for all of Europe. We're going to get the 75th percentile and the 25th percentile for all of Europe for each year. Okay? I'm going to put it in a mutate, and then let's see. I do arranging and selecting. These are not really necessary. It was really when I was looking at the results to make sure that everything was running correctly and just seeing what it looked like. Yeah, so you can really ignore these last two. Remember, select just selects columns. So I just kept year and one of the things that I estimated in mutate. So anyway, WID, filter, group by, mutate, and within mutate we create three variables. Med-Gini is what I call it. You can call it whatever you want. It gets the median function for Gini reported, which is the estimated Gini score for that year for a country, you know, however it's observed from whichever think tank or government institution or NGO that is estimating it. So median, Gini reported, and remember to include for basically any statistical function, make sure to include the na.rm equals true, so that when you do things like min, max, median, mean, standard deviation, quantile, all these things, that you make sure to remove the NAs, otherwise it will not estimate properly. It will kick back at error. So median, and then I call the next one Q25, which is quantile. This is the quantile function. And the arguments, this is new. I have not introduced this to you before. The quantile function looks at a distribution of a variable, arranges the values, the observations, and then says which value is at the 25th percentile or at the quantile 0.25. And we're looking again at the Gini reported. So this should give us the value that would be if we were creating a box plot by year for Europe. This is the value that we would get, that we would draw at the bottom of the box. The 25th percentile would be drawn at this particular value. So this is just going to produce that value and repeat it through the data set for any given year. And that is also true for the next line where I say Q75. I do the exact same thing. I just copied the line for Q75 and 0.75 for the quantile. That is at the 75th, 0.75 quantile, the 75th percentile. This is the top of the box if you're creating a box plot. And then I did some arranging and selecting, which we won't even see because I'm creating an object here. We could look at it very fast. And you would see, now again, we have different countries represented, but they're all getting the same value, if that makes sense, for those that are in Europe, because for all of 1952, we've created the exact same Med-Gini regardless of the country, and the same 25th quantile, the 25th percentile, the 0.25 quantile, the 0.75 quantile, or the 75th percentile. All right, so it looks like it was doing what it was supposed to do. Geom segment is the function that we're going to use here. Geom segment requires a minimum of 4 aesthetics if you don't include things like color. It requires an x end, a y, and a y end. So think about it, it's just asking for coordinates for the beginning and the end of a line segment. That makes sense. You probably haven't seen an aesthetic yet that had the end part attached to it, but there are 4 aesthetics here, and you can actually make 2 of them the same, for example. So if we wanted the line to be vertical, we would make x and x end the same value. That way the x doesn't change even when the y does. Or the reverse of that, making the y's the same, the y and the y end the same, would give us a horizontal line when the x's change. Okay? So in this case, we're going to actually make x and x end equal the exact same thing, but then y and y end will equal different things. Okay. here it is. It's pretty simple. I mean, now that you've been introduced to a bunch of geoms, new geoms aren't that difficult to learn, honestly. It's just about learning what they do and what aesthetics they take, those kinds of things. So we take the width sub, we pipe in, oh, I don't know what just happened there. I accidentally closed that window. You're getting a preview of what this is going to look like actually at the end. Okay. Width sub, ggplot, piping right in. Don't need to put the aesthetics on this first line if you recall. You can start the aesthetics on the first geom line as well. Geom segment. AES x equals year, because the x-axis for this is going to be the year. The x-end for any given segment is also going to be year. Okay, so meaning the beginning and end of the x, so the beginning and the end of the segment should be the same year, should be the same value on the x-axis. That'll make a vertical line. Then y will be the Q25 that we created, so it'll be the lower quantile of what would become a box plot potentially in another type of geom. And then yn becomes Q75, which is the 0.75 quantile, the 75th percentile, which would be the top end of the box if we were making another geom like a box plot. And then I just add a theme minimal to get rid of the default gray and some of the things. I don't clean up anything else here. And the resulting plot looks something like, well, let it stretch out a minute, this. And let's talk about what this looks like, what this means. So this means that for any given year, this little bar, this little segment represents 50% of the information for that year, right? The middle 50% of the observations for the Gini index, the Gini score, are contained between about, looks like about 41 or 42 to 45 here. And there's a pretty clear pattern that's happening to the middle 50%. And you can combine this with something like, oh, I don't know, the median. And you can really come up with something, because you're not only then talking about everything that we've done so far has been like, let's work with a median. Now, maybe we've been using a geom smoother, but the geom smoother really gives you, it gives you a standard error around a moving mean, but the geom smoother, as we've been using it so far, uses a low S smoother, which is a little bit different. It's kind of a rolling average. It's a form of a rolling average, I should say. And what we are doing here is a little bit different. And I think it makes a nice visual, especially if the values that you have are discrete in that they're integers, right? We don't have different months or continuous measures, really. We have an estimate per year. And so this actually kind of makes sense that we would do something like this instead, because they're actually discrete metrics that we have. So it makes sense that the visualization should match. And we get to see the evolution of the middle 50% of the data, in addition to, let's say we wanted to add the median. We could add a geom point. You would want to change the aesthetics. The X would still be the year. The Y this time would be the med Gini that I created above. And we could literally just add it right on top. We're still coming from the width sub because we created it right here, right? I just added that line. And what's going to happen is, I'll maybe change the size a little bit. I'll shrink it a little bit. Maybe I'll make the color red for randomness. It's a little bit bright. I would probably, in retrospect, I would either dial down the black lines to a gray, or I would change the color from red to something else. But you can see the little red dots now at the medians. So you can see we're getting different information than what we've been doing where we've done something like the mean and like a smoother. This is really useful. It gives you a different kind of sense of confidence or uncertainty, certainty or uncertainty, confidence or lack thereof about what you're reporting. If you're just reporting a measure of central tendency like a mean or a median, that's usually not enough. If you want to really do proper, valuable, meaningful statistics, you want to also present some measure of uncertainty, and this is one way to do that. And this will be useful for the week 4 assignment. So I hope this is helpful. This should help you complete the final problem. Have a good day.